So, this talk came about because in early November I was under siege we had a whole lot of issues with teaching, and life was very complex, and Beverly and Claire got in touch, and in fact Simon Conway Morris as well, and said, do you want to do this talk? And I said, oh, well, sure, that'd be fun. And then about a day later they said, what's the topic? And I was thinking, oh my God, I can't, Cambridge Philosophy Society. Okay, maybe I did a talk ages ago about should we automate. So I said that, and then sort of forgot about it for a while. And so then in the sort of late December, early New Year, I started to worry about this. But anyway, so I should say, I think probably the only thing I don't do in this talk is answer that question. So apologies about that, but I skirt around it from all sorts of different directions. So quick acknowledgement, there are other people as well, but a number of people here and not here have helped with getting this talk together. And I'm a college philosopher, Alexander Bird, I sat down next to at dinner the other night, which was really useful, because I said, just explain the philosophy businesses to me. And so anyway, I don't think I really picked it all up. And there's also another group of people I have to thank, because they're the people that have kind of done this talk before, which I hadn't been aware of until I'd committed to doing the talk. So Liam Bagrat did the 1964 Reith lecture, so I should have known about that. I was 1 year old at the time. But Stuart Russell did the AI talk. Daniel Siskin did a series on automation on BBC last year, and Mary Barker did a thing on the automation of peas. Which was very interesting. So anyway, everyone's doing it. So why am I doing it? Well, I view automation in a slightly different way, and I very much have a practitioner's view on automation, and for I've been involved in automation for a long time, too long, not more than 20 years, but actually more than 30 years, and so my perspective is from industry. And having seen how digital systems grew out of industry. But I'm very conscious of, and have been conscious for the last 10 to 15 years, that there's this societal view and about automation, and quite specific views, and the implications of AI, what are robotics doing, the economics of automation. Some of it I understand, some of it I don't understand, and some of the puzzles I have with that will come out in this talk. So I've tried to take a middle ground where I am a practitioner, but I'm trying to think about some of the implications about the way we do automate. So I'm going to go back to some history. So I was reading this book, Neil McGregor's book on the history of the world and the 100 objects, and came across this lump of rock called the Olduvai hand axe. And I thought that's a good starting point for the talk, because one of the things I see as central to automation is a tool, something that puts a mechanical device in contact with the thing it's trying to transform or affect. And this is a fantastic thing, because it was actually the main tool that was used for about 1 million years. Now, of course, I'm sure there's some artistic license in the book, but the notion of anything lasting 1 million years, and you can imagine, 300,000 years into everyone having an Olduvai hand axe, going, oh, I wonder what we're going to do next year. And actually, the same. They all kept using hand axes, but actually, automation did move on a bit quicker after that, and so this is my attempt to scribble down the history of industrial automation on a page. And I know I've left out quite a few things, and they're predominantly the things that I couldn't draw easily. In fact, I deeply regret having attempted the Jacquard machine in the centre there, because it was rather tricky. But so the main point I want to make here is not to take you through the history of automation, and I won't point the laser in my face either. But there's been three main threads that I okay. There we go. Three main threads that I think are important to mention. There's What tools? So the interface between a machine and something that has to get done. And that the grinding wheels are examples of tools. A lathe is an example, a powered lathe, an example of ways of getting metal, cutting metal. And in fact, robots that started to appear in the 1950s were essentially a tool on the end of a long arm. And the second thread is motive power. So going back, water power has been around at least since thousands of years BC. But actually one of the big, and I've even left out steam power here, no drawing space, but electric motors were really important early in the 20th century. And then the other piece, which I'll talk a lot about, is the stuff in red, is something to do with programmability and governing and regulating processes. So James Watt, 1788, and in fact Huygens, actually in the 17th century, more or less had the same idea, invented this thing called the flyball governor, which allows you to control flows of things like steam. But the Jacquard machine was a means of managing weaving through punch cards, which actually was one of the first ideas for programming. And as we go forward, in the early 20s, we started to connect circuits together to actually regulate processes, something called the programmable logic controller. I see too much of in our lab, and actually, these things today are being used very heavily, so, in industry as well as obviously elsewhere. So that's 200 years, a snapshot, but not a superbly accurate snapshot, but just to give you an idea. The other relatively long period of time has been the time I've been involved in automation. And this just, as Claire said earlier on, I've been involved in automation in many different areas, and that just sort of captures the thread from early days in steel to working in automotive and consumer goods when I first came here, to airlines. I even left airports out, which I could have put in, and as the logistics program Claire mentioned a moment ago, and actually we're working with SMEs, which is a code for small companies at the moment. So I've done a lot of practical work in automation, and that really is the key point. The perspectives I'm going to talk about about automation are not an economist's view or a policy person's view or a computer scientist's view. It's really just from someone who's been doing it for quite a while. So I also, as I said, about 10 or 15 years ago, I started to sort of think about see these articles about the future of automation and started to think about what we were doing. And actually it was, I think when George Bush said the solution to the climate problem was to put all these mirrors in space and shine them back at the sun, I started to think maybe every now and then we ought to think about what we're doing and why we're doing it as well as how to do it. Because, and so somewhere about 10 odd years ago, I wrote this poem, and I think this is my only engineering poem. It's quite a difficult topic to to write poems about. But you don't need to read it all through. It's not a great poem. But the message was, as engineers, we often are very good at how, and sometimes what we're doing and why we're doing it get lost in the translation. So actually, most of this talk is about what and why, to make up for the fact that they've been left out. So the talk is really in three parts. I'm going to just spend a little bit of time giving my view on what automation is, and I hope it's not too dull. I should say there are a few extracts from my third year lectures, but students find them dull actually. I'm going to talk about why we automate in a little bit of detail, because I think some of the issues around what we do in industry and why we automate in industry actually have some ability to help us navigate through some slightly choppy waters coming up as automation is used more broadly across society. So, onwards, what? So I'm going to focus on two things about when we're talking about what is automation. Firstly, actually what it is rather than what you read in the papers, and then what does it mean for us? So, firstly, in the public eye, actually automation is something we're dealing with every day, and it doesn't mean there's a robot in every room. It doesn't mean a computer's taking over your life, but I've just put some pictures of some of the day-to-day objects that are actually automated, some of them pointlessly, like that electric can opener. Sometimes the sort of questions we need to ask ourselves is how invasive are these systems? When are they beneficial? Like the checkout at Sainsbury's, it's kind of beneficial, but you might every now and then I feel like we're doing a lot more work at the checkout than we used to have to do. When do we really need it? And also how much autonomy, how much thinking space are we comfortable with automated systems having? And I don't know if anyone's seen this picture, but I just came across it the other day as I was walking around the West Cambridge side. This is the new autonomously guided busway for West Cambridge, or the bus on the busway. And it's going to be doing a rather limited loop to begin with. I think from Sainsbury's to the astronomy lab. I don't know why they need that, but I think what's very clever about this is not its autonomous nature, but the fact that it also already looks like it's had multiple car crashes before it's actually been launched. And I think that's rather anticipatory, actually. So I was impressed by that. Anyway, just some views of automation in the public eye. And then an interesting thing, what does industrial automation mean to people? Well, we could do a survey, we haven't got time, or perhaps people wouldn't be interested enough to do it. But industrial automation, if you go to Google, these are the first 12 pictures you get. So the overwhelming message there is robots. So I think, is there one where there's no robot? I think the one up the top, third from the left on the top has no robot. But they're pretty dominant, and I think that is a perception that then tends to feed all sorts of debates and discussions, not just in industry but elsewhere. So I want to just evaluate that a little bit and see how that measures up against what I've been doing. And I should have said earlier when I put up the 30 years of automation, as we go through the talk, I'm going to use automation developments that I've been involved in to actually sort of illustrate most of the points I'm trying to make. So before I do that though, we need a definition. We don't need a definition at all, but I actually wanted to put this in partly to poke fun at the Oxford English Dictionary, really. But some issues here. Automation is not just about machines, it's about computers. It's often using them instead of people, but not always. And it can be in a factory or an office. So I think Cambridge Dictionary actually is okay. I'm happy with that. The Oxford definition, if you were asked to define what is football and you said football is about kicking a football, you'd be in trouble because it's too recursive. I think saying automation is the introduction of automatic equipment is along the same lines. So anyway, sorry about that. And then Britannica makes the point that automation helps to focus on tasks that might otherwise be impossible. I'm going to come back to that in the end because I think that is an interesting issue. So over with the definitions, and those of you that have ever been to my third year lectures will be thinking, oh my God, he's not going to start one of his lectures. But I always include this thing, and this is called a feedback loop. And I somehow managed to get this into every talk I give. Sometimes I get quite a few protests. But essentially everything we do in life fits around this. Any operation we undertake, we have to sense what's going on. We have a set of requirements we're trying to achieve, and we decide, do we need to change the way we're acting in the operation to change it? And I was thinking about this last night, cutting carrots actually, making dinner. And you know, you could, if I'm cutting carrots, then I'm looking at the thickness of the slice of carrot that I get, and I've got for my stir fry, I've got an image of what sort of thickness I need, and then I need to decide whether I need to press the knife up a bit closer to the edge of the carrot for my next cuts. And of course, that's rather simplistic, but you know, that's a feedback loop basically, and all in every way, these sort of loops run industrial processes, and actually they run most of our lives as well in one way or another. And so when we talk about automation, actually what we mean industrially, so we're actually doing what could be done manually in an automatic manner, we're really talking about taking one of these activities and using something automated to do it instead of the human eye or brain or hand. So that's automation kind of 101, or 3P2 as the lecture series is called. So there's a lot of technologies that get used in the context of automating industrial processes, and you know, most industrial processes involve something like this list down the bottom: cut or add or heat or mix or assemble, move or store things. And to do that, I need to come up with some sensors, and the sort of sensors range from very simple barcode or that pointy thing which is a thermocouple that measures temperature, to actually your phone is a pretty good mechanism for sensing stuff these days. And there's something called Internet of Things, which you might have heard about. If you haven't heard about it, don't worry too much, we're not going to go into it, but it's connecting up a whole lot of sensors together. But I need to actually make decisions, and to decide, we use computers. We do use that strange brain-looking thing. Is the sort of thing, if you do a Google search on AI, you get this sort of crazy-looking picture, which is a person's face with lots of stuff going on behind it. But you know, AI is, although it is a way to make decisions, it's not what we normally do industrially. We use these programmable logic controllers, we put stuff into databases, we manage information and generally make quite simple decisions. And then we have to act. And again, if we have to act, a robot is one way to act. But there's lots of other ways to act as well. We might just put things on a conveyor. Things may end up on a conveyor. We may have a simple switch, a motor, or a solenoid valve, or a simple actuator, are all mechanisms for acting. So don't worry about thinking, what on earth are all these things he's putting up? The only message is there's lots of ways that we can do sense, decide, act. And the reason I'm emphasising that is that if you pick up the press, the popular view is there's only two things going on. In terms of automation, there's AI and robots. And they certainly play a role. Well, actually, AI plays only a minor role these days, certainly industrially, it may in the future. But my point is there's a lot more to thinking about how to automate issues that we have in our lives than just looking at these two technologies. So, just to show that I'm not completely opposed to AI and robots, I'm going to just try to play a little video, which is, this is, so 20 years ago we were using robotics and AI in our lab, and the reason we were using robotics and AI in our lab was we had a I keep holding the wrong pointer. This is a little warehouse shelf, and we were making gift boxes for Gillette. Why they couldn't just put them together by hand is a different question, but we were at the time. And the thing is, warehouses get messed up. And this chap here, who's somewhere in the audience, can't remember where he's sitting, but he had more hair then, and he and I were going in to mess up the warehouse, and the robot charged with AI was going to unravel what was going on and sort things out. Now, unfortunately, this video mainly shows the messing up of the warehouse.
It's going to simulate a human error by moving an item into the wrong location in the warehouse.
that we broke many rules.
In this case, a
where-
razor is placed amongst the foams, although the system can actually detect and deal with any combination of errors.
So essentially we're taking items from one place and shuffling them around, taking them out, moving it, making a mess of the warehouse. And eventually the robots...
Following the modification, the warehouse is put back into operation. As soon as this happens, the RFID readers in the cell detect the error and command the robot to remove the offending razor from amongst the foams and put it back to the left-hand end where it belongs.
So that was 20 years ago, where we were understanding the role of very simple AI and robots in a laboratory environment, but with the idea that we'd be using it soon in industry. So what I want to go on to now is to talk about what we've actually... Oh no, sorry if you don't want to hear it twice. Is to talk about what we've actually been doing over the last 10 or 15 years. And I've used two data sets in doing this. Again, don't worry too much about what you see on the left-hand side. What you've got there is an assessment process we developed for looking at automation opportunities in different factories, and this represents the outputs of 4 different factories. And combined, the rows of these were different automation opportunities that those four factories had identified. And the interesting thing was, so we actually over the weekend, my colleague Alan Thorne's done some mining of this data and identified that we actually found 622 different automation technology options in those 177 opportunities, of which one of them required AI and 57 required robots. So about 10, slightly, and these were large companies, and about 10% of the applications might have used robots, and only one required AI. And the rest of the applications actually really needed basic logic and maybe some simple mathematical models of the operations, as well as sensors. So that, the main point I'm making there is these technologies that you read about in the newspapers are far less dominant in life than we'd maybe be made to think, at least at the moment. So a second activity we've been working on for the last 5 years is a program called Digital Manufacturing on a Shoestring, which is about doing very low cost automation solutions for small companies. And this is because many small companies are unable to consider getting involved in large-scale automation projects. And anyway, throughout talking to hundreds of companies, we've identified 59 low-cost solution areas that small companies would like to have. And we've actually done prioritizations of these. And so across those 59 solutions, talking to upwards of 300 companies, we identified 196 technology options that support those solution areas. And again, the main point to pick up is these two dominant technologies in the press don't really get much of a look in. And it's not saying that we may have used them more than we've stated there, but it's certainly not the dominant automation technologies. In fact, over and over again, we're finding that sensors and basic logic is what's used in most automation environments. So that's really the first point I wanted to make. I'm labouring it, but it's really important that there are a lot of different elements that contribute to what we consider automation, both in industry and elsewhere. These are the sort of simple solutions that come out of this. This is a vibration monitoring of a 3D printer, and using a tablet to look inside a warehouse to actually find out where inventory is held. So the second thing I want to talk about in the what category is people and automation, because maybe there's some misconceptions about the ways that people get and automation interact or automation takes over the roles of people. So The first, the one I think we understand and hear a lot about, is that people are eliminated by automation. And the example I'm using is a system we developed to track high visibility jackets in underground construction environments. And certainly, rather than going looking for the jacket, you can track it. And there's lots of other examples of work we've done like that. So that did eliminate a job for someone that would have to go and look for those jackets when they got lost or misplaced. A second class of areas where automation interacts with people is that it does, helps. In times it reduces the role tasks that people have to perform. In this case, we've just finished a project with a company that makes building frames, and their job is to, when they're putting a house together or elements of a house together, they've got to track where all the different bits and pieces that go into one house are. And this job state tracking system actually doesn't take someone's job away. Someone's still got to go and manage where all the bits of that job are, but it reduces their load. And then a third category is actually automation that enhances people's work. And this one goes back a long way. This is actually the first automation project, well, one of the first projects I worked on, and that's Colin there. And this was in a steel mill in Australia. And we basically, a big problem in a steel mill is if one set of rollers is running out of sync with the other set of rollers, either you stretch the steel and break it, or you buckle the steel and it flies into the roof and makes a hole in the roof. And it's at about 800 or 900 degrees Celsius. So we don't want that to happen. So we built a system, rather than the operator just looking at the speeds of these rollers, we built a tension prediction system. And that enhanced his job of manually changing the roll speeds in order to keep tension in the steel at the right level. So that's three different ways that people in automation interact. There are some other slightly wackier ones. This is one example that's not something I've worked on. But I think I have worked on it actually. So anyone that's put together an IKEA bookshelf or bed or something like that will know about this. But there's a whole class of automation tasks that have actually enabled the shifting of work from the producer to the consumer. And this is a great example, as we all know. The other one is the supermarket checkout, where we're all doing the work rather than the supermarket these days. And then the final category is the category where there are tasks or industrially where there was actually no possibility that a person could have carried it out themselves anyway. And some work that our startup company Redbyte has done with the United Nations Postal Service has been about tracking. This is an interesting story. The way you work out how to pay for a stamp. Who gets the money when you pay for a stamp is through letters that get put through the post. They're dummy letters. They have an RFID tag, radio frequency tag in them, and they get tracked going through the different mail sorting centres around the world. And there's hundreds of thousands of these sent a year, and the amount of time spent in different countries and the performance of different countries' mail service is how the value of a stamp gets distributed. So that system operates in upward of 100 countries, and it's certainly not the sort of thing you could have ever done manually. So that's what automation is. I'm now going to just briefly talk about this question of why, why we automate, and clearly, there's some reasons because we read it in the papers. And the reasons that come up in the papers are things like the UK has a productivity problem, we need to automate more, or within an organisation we need to reduce the labour cost in our business, or there's a local labour shortage. And these are half reasonable reasons for automating, not always exactly correct, but they're reasonable reasons. But often, from my experience, the type of reasons that have often been used for automating can actually be of a different class. So it could be, I've seen that robot in someone else's factory, I want to have one here. And I've experienced that a number of times. There's a government subsidy that's available, so make use of that. or there's a headcount target that gets imposed with very short notice into a part of a business, and they therefore buy automation systems to help remove people, or there's short-term capital availability. All of those are seen as rationales for industrial automation, and in fact the best one is this one, that automation creates jobs, which was part of a survey that was done about 15 years ago. And I don't think, we could do a show of hands who believes that. I don't think automation directly creates jobs. The main thesis in that article was they looked at the loss of jobs in automation over a period and the growth in the digital industry in the UK, and concluded that there was growth. But I think the correlation is still to be determined. So I actually have for me, and I'm not going through, I have a couple of lists, and I promise I'm not going through them. In fact, when I showed it to a colleague the other day, he said, "Why have you got those lists?" I wanted to put this list in because this is actually a pretty good list of reasons you might want to automate and not want to automate. And the source of this list has actually been my third-year students over the last 10 years, who each year we actually start the course by talking about some of the reasons that you might want to automate and why you would not want to automate. And on average, it comes down to two basic elements and a third one. So performance, what benefits can you get? What does it cost? And then there are some human issues that get looked at to a certain extent. But there are important negative sides to automation as well as positive sides, and I think that's the main point to make there. So actually, when I first was working in the steel industry in Australia, the sort of calculations we did were along the lines of this sort of thing that I've extracted from an old record of automation systems. But essentially what you do is you would sit down and write down what the costs of putting the system in were, and you would then do some expected performance benefits. And generally there would be, it's that word expected, we'd often have to come up with do expected. And at one point we got called up to talk to a steel mill manager, and there were three of us that were doing research projects in his steel mill. And he said, "Do you know, I've just added up the expected benefits of all your implementation, and I can basically stop running the mill because I think we're going to make money from here on, whatever we do." And we'd given him, I think, 120% output of the total possible output he could have. So the numbers didn't quite add up. So there was, at best there are some loose methods. So one of the challenges is that people tend to underestimate costs, and the benefits don't deliver. And those, just some examples of that that I've been involved in. A baked bean factory that wanted to track batches of baked beans throughout its factory, put a tracking system in at the exit from the factory, and realised a year later they should have put it at the entry. In the steel mills I worked in, we've spent a huge amount of money upgrading what's called a plate mill, because a plate mill rolls steel plate out to certain thicknesses, and there was a great niche in the market for thin plate, so we upgraded the mill mechanically and forgot to upgrade the control system. And by the time the control system that managed the mill was upgraded, the window in the market was gone. Alex Wong, who might be here tonight, I think, was involved in some work we did with a number of the retailers in the UK about 15 years ago, and we looked at the benefits of putting tags on products on consumer shelves, and we were very keen, but when we actually looked at it, you can't quite see, it's a 3D graph, but the gain in putting monitoring tags on items on shelves was really very small, because one of the key things was the supermarket at the time only replenished once a day anyway. So it didn't matter if you knew that you're out of digestive biscuits, no one was going around to put more on the shelf for another 6 hours anyway. So failure of the cost-benefit analysis. We did have one great gain when I was back in the steel industry. So if anyone knows what Ethernet is, it's kind of the backbone of all our internet operations now. We could not get the benefits to add up to install Ethernet, which in any factory. And we worked at it, and the forms just didn't allow us to write down this could give you a lot of great new opportunities. So we eventually found that if we count up the cost of the copper cable we might save, we had enough to upgrade. And they then, I think, made 100-fold benefits in the following years as a result. So every now and then the cost-benefit analysis helped out. So where we've gone from there, and again, this is one of those diagrams that you don't need to spend too much time absorbing, is we're a lot more systematic in the way we understand and try to capture all possible benefits, as well as the potential for those benefits not to be delivered. And this is just a diagram a students recently produced as part of that shoestring program, where we work with companies to help them identify all the different potential benefit and cost areas that they're likely to be they're likely to experience. But that assumes you have the opportunity to work with companies looking at that, because quite often, and this goes back 10 plus years ago now and longer, you encounter companies that say that they are determined to automate regardless. And the first thing I ever looked at in the steel industry was a problem of a galvanizing line. So this is steel wire going into a bath of galvanizing solution. Pretty unattractive stuff, actually. And what would happen is, when it came out the other side, the liquid would accumulate on the wire, and they needed a mechanism to bump each wire to knock the excess liquid off. And so anyway, we went along to have a talk to the factory manager. He said, I want a robot doing that. I said, well, you could just have a little mechanism that banged it, which cost $100. He insisted on a robot, so he had a robot. Again, we're working with a company that was doing off-site house manufacturing. They were moving construction into a factory. They wanted machines to do it, even though at times there wasn't a benefit. And we talked a couple of years ago with a company that does retail warehouse. They delivered, they do online supermarket shopping. And they said, we want to automate our warehouse completely. And we said, well, why do you want to do that? They said, we want to. Anyway, so we parted company because we couldn't actually get any rationale apart from they wanted to do it to see how it worked. So a lot of the challenges we had were around people that would come to see us and say, we want to automate. We're interested in automating. We want to automate this thing. And so, along with colleagues Alan Thorne and Liz Salter, back in 2012 or 13, we wanted to do something to stop people heading down an automation path when they didn't need to. And these are the sort of questions we raised at the time, and in fact then turned it into an auditing tool. And this tool we've taken out and used in a lot of different organisations. But the idea is you do what we call a pre-automation assessment. So you look at your ideas, what you've got, and actually you take those ideas and plot them. And of course, it was a consulting tool, so it had to be 2 by 2. It couldn't be any more complex than that. But the key point is, unless it was both feasible and opportunistic, we wouldn't go ahead. And generally, what we found is that quite a lot of the opportunities that came out of our opportunity and feasibility assessment, a lot of the possibilities actually sat elsewhere other than in this top right corner. So the main point to say is actually getting to the system before you make a decision that you're going to automate something is the right thing. And again, I'll come back to why that might be important in broader society in a moment. So that gets to the end of the what and the why piece. So essentially from a what point of view, I think the two main messages are there's really a lot more than AI and robotics in many and most automation solutions. And also, the role of people working with automation isn't as simple as automation removes jobs. And we'll come back to that again in a minute. And then on the why side, although there are systematic approaches, not all industrial automation is in any sense wisely chosen. So looking for industrial direction is not always the best thing. And also just, I think this last point is really critical, is like understanding and assessing the need before committing down an automation path. So with that, with those learnings from industrial automation, just the last part of the talk is now just going to talk about how automation might influence society in the future. So again, I apologise that someone will say you didn't answer this question, but I think I'm answering some questions around this question. So first thing is, as I said, in the papers we are seeing quite a barrage of information about automation developments. So the government is going to become, UK, we're going to become an AI superpower, which is good news, I guess. And we are spending a lot. I think we've spent £12 billion on AI as a government since 2014. So that's quite a significant investment. But Singapore is transforming its city through automation technologies. China has a 5-year plan for robotics. There's a global race going on. 50% of US healthcare providers will have robots and process automation in 3 years. And this is actually my favourite one. The UK manufacturing lags dangerously behind competition. That's a quote from the head of the UK Robotics Society. So I guess, but I don't know what dangerously means, really. So what's definitely true though is automation's reach is extending, and it's been something that's been thought about for quite a while. And I'm just going to play a little clip from Modern Times, where Charlie Chaplin knew what was coming back in 1936. So this is showing how the ideas from the factory could be directly brought to bear on a day-to-day life. So it's almost utopian, isn't it? I could certainly do with that. Yeah. So it goes on. Things get further out of hand. So and actually he was a pioneer for the right of the worker, and he took it very seriously. And the aim of that film was to warn about the threat of automation extending into our lives. It's quite a dark film. Let's not have it again. But I think So what is certainly true, and I think it's certainly occurred over my lifetime as an automation engineer, is that automation that was predominantly for me an industrial technology has now started to become relatively commonplace in in many other aspects of life. And I think one of the key points to make here, if you compare the two industrial scenes on the left to the 3 or 4 scenes on the right. By the way, that's an automated lettuce picker. We haven't developed one of those. We worked on the preliminary side of lettuce picking earlier on. But the key point is these are structured environments where there's not too many employees running around. The employees are kind of actually work for the organisation. There's a flow of goods that's relatively predictable, whereas these environments are relatively complex, if could even say chaotic. They involve a mix of employees and consumers, and they're subject to weather in the bottom two. So actually taking industrial ideas of automation and thinking about them in a non-industrial context is something that needs to be done very carefully. So, having said that, there are a significant number of challenges coming through at the moment that in many different walks of life that automation is being asked to look at. And this comes out of a study that my colleague Alan Thorne and I did 5 years ago, or 4 years ago, which was we were asked to look at the way automation is going to can support society's challenges in the future. And we had a number of workshops and a number of other interview studies that we put this information together with. So I'm not going to go through all of that. I mean, this just picks up some of the challenges. But the main point I want to make is, on the next slide, is that if you think about that sense, analyse, decide, act diagram we did at the beginning, if we look at where we are today, and this is actually probably 3 or 4 years ago, but still reasonably accurate, then the dark areas are where there's a lot of automation work. And my colleague Chandravalu pointed out to me the other day, this shaded diagram could equally have applied 100 years ago. By far the dominant areas were around discrete industry, military and transport. Our projection of where things would be going within 10 years is that you would start to see automated sensing in vast areas of human society. And I think we're already seeing that going on at the moment, but a significant growth in areas like food and resources, around our cities, in healthcare, etc. And then 20 years, we'll have a very significant amount of automation. So I should say, it's not going to be the automation that's robots and AI, but there will be automation of the sort of things that I was talking about earlier in terms of some of those basic technologies that help you automate different processes. So what I want to do in the remaining slides is just gather together some of the different areas in society that we might need to keep in mind as we go forward. So firstly, from a societal point of view, I think it's becoming important that we can understand the difference between good and not so good automation. And this is I don't know if this is the right set of criteria, but for example, when we automate, we'd like to get like for better task replacement. And I really struggled to come up with an example for that, but in the weekend, our students were running a weekend hackathon in the Institute for Manufacturing. I was starving, and all I had was my Visa card, and I went to a machine, was able to get a flapjack, and I thought, well, that's good automation. I haven't got any coins, and it was able to read my card and give me a flapjack. So, but other areas where we might really want to think about are cleaning up the oceans. If you've got some of the mess is on the surface, but a lot of it's down below. We're not going to be able to do that without an automated environment. So there's lots of issues where we might say automation is good, and other areas where we might say automation's not so good. Anyone's had a struggle with a call centre at the moment will realise call centres haven't quite cracked automation yet. It's certainly gone backward. Well, we've gone backwards there. One of my great bugbears is the leaf blower, which I would call, I'm not sure if it's a convenience automation or a health reducing automation, but I just don't see why we got them. But anyway, that's a personal view. And the other thing I would like to think about is fashion automation. And I've got anything against Xboxes or PlayStations, but they do upgrade very frequently, and whether they really need to be upgraded that frequently, I don't know, because the waste, it must be considerable. The amount of R&D effort and thought power just giving us all these different PlayStations seems probably excessive. And there's many other examples like that. So that's automation in society. And then for the people that are doing jobs, what does automation mean for us? Well, so this is essentially a simple chart which tells us about task automatability. In the bottom left-hand corner is easy tasks to automate, and the top right-hand corner is difficult tasks to automate. So things that are non-cognitive, don't require too much thinking and routine, they're pretty automatable. And where we've been moving over the last years is on a diagonal line in terms of automating of different tasks that people do. And there's lots and lots of papers written about this, and I'm just skimming the surface, really. And that line's moving up and up and up. So again, remember that some humans do lots of tasks in their job. Some tasks are replaceable, some are reducible, some are enhanceable. Secondly, most jobs have lots of tasks, and so it's actually it's quite rare that you can completely replace a job with a collection of pieces of automation. And even if one of the issues that's come up in the AI debate is it's one thing being able to automate a task or a couple of tasks, but actually automating the process the person often goes through and choosing which tasks to do at a given time is a really difficult challenge. And in fact, so this chart just gives you a sense of the types of roles for which more or less 100% replaceability has been identified, down to roles where where difficult, complicated, different decision-making processes are required, very unlikely to be automated in the near future. But so there is issues around automation and people, and just an observation, because we've been through lots of cycles. We've been through agriculture, industry, services. We always find more tasks to do. It's just we've got to find money to pay for them is normally the challenge. Then the benefits and costs I won't go through because we went through them earlier, but benefits and costs of industrial automation actually apply more or less for any societal automation. But there are some other things to think about, such as the cost of unemployment costs, the retraining costs, the motivational effect of automation, or where you're reducing removing people's jobs or reducing the complexity of their jobs, and then sustainability. And I won't go through the list of the sustainability issues either. But just a point to make is, if we're moving from a petrol society to an electric society for vehicle movement at the moment, one thing we really need to think hard about is are we actually counting up all the negative costs in making that transition and managing them? Because it's a huge infrastructural change we're heading towards. So I'm very pro electric cars, but I'm not sure whether we've really thought it out, and we still should be driving less. And then this other one is when we go through all these phone upgrades, what happens to our old phones, and do we really need all those new phones? Do we really need to update a phone every couple of years? Just thoughts about the way in which sustainability, and I call a phone a major piece of automation. So the sort of thoughts I've been having to look at the way I do my automation, which may just help us to understand the way we consider automation in society, is a balanced model where we don't just look at the benefit and cost assessment, but look at these other three factors I've talked about as well. And I actually just out of interest over the last week, lacking something else to do, I guess. I did a bit of a self-assessment, and so for each of those 4 categories, human, society, sustainability and benefits, looked at the projects I was involved in before 2010, and blue is good, grey is not good at all, and orange could be better, I think. And just, I think at least there is some sign that the projects I'm working on are improving because of not because of any great strategy on my part, or my group's part especially, but just because the type of things we look at are better. But actually, if we look at it, we've probably had 12 deployments out of 25 before 2010 that were positive on that balance assessment, and 25 out of 28 since. Although, to implement them, you need a positive cost-benefit analysis. There's qualifiers. This is not real. This is not definitive data in any sense. It's just indicative of how you might use that type of self-assessment. And if I have got that self-assessment or that assessment process, and I could use it to prioritise, an interesting question then we need to finish with is who pays for the automation, and how do we actually influence, if we've got priorities, how do we influence the people that are paying for automation? So 3 quick ideas to finish on. Firstly, we have existing incentive schemes, but we don't use all of them perhaps in the right way or in the best way in terms of prioritising automation. So R&D tax breaks could be used, and in fact at the moment anyone that wants an R&D tax break and does some R&D can get support, but maybe it should only be in the highest priority areas. Or the UK has a £8 billion a year research institutes funding budget. Could we actually only work on areas where there's social impact? Secondly, could there be such a thing as automation screening? So as Claire said, I've spent a fair bit of time in the last 2 years working with the hospitals and more medical areas. And what's amazing there is the amount of screening that goes on before a drug gets to the market. Well, that never happened with the mobile phone. But although admittedly there is work going on, this Alethea framework that Rolls-Royce has proposed is a framework for assessing the ethical impact of artificial intelligence and robotics. Not all automation, but it's a start. So that's a second area. And then the third one is, Bill Gates put out a statement a couple of years ago. I think he regretted it in the end, saying that all robots should be taxed. So, and his idea was you put a robot into a factory and you remove a worker. So oversimplistic, but that person is no longer paying tax. So we should be taxing the robot instead. And I think what the Robot Institute's then turned around and said is, well, probably could do the same for Microsoft Windows or Word or something like that. And anyway, things went very quiet there. But so there could be laws on automation. The European Parliament had a look at robot taxing and gave it up, but decided there needed to be laws. And they gave it up because it was going to stifle innovation in robot development. Interestingly. But they are looking into regulatory laws, and we could be better. This is not my drawer at home, but I have got quite a few phones lying around. I found one in my underwear drawer today for some reason, an old one. So we've all got lots of these, but we don't actually. We should be paying for the fact that we're upgrading, in some way. So anyway, that comes to the end of the talk, and. The great thing about doing a Cambridge Philosophy Society talk is I don't feel I need to actually end with a set of next steps, which pretty much every other presentation I ever do does finish with. But the only thing I'd like to finish with is that. So that and I just wonder, for something to be used for 1 million years, and it was basically the Swiss Army knife of its time. Is there some message there? Maybe we're trying to change things too fast, too quickly, and not think about the implications. I'm not saying we want to stick to our mobile phones for 1 million years, but you know what I mean. So on that note, I'll stop. Thank you.